Hi guys, we're moving on today with proofs with parallel lines. Our objective will be to use corresponding angles, Converse, and the Transdib property of parallel lines. Students will be able to prove theorems about parallel lines. So again, if you guys are following along with the guided notes, this is a good thing to write at the top underneath the objective portion. Take a minute, pause the video if needed, and I'll try to give you a second. Okay. So first up, we have a theorem, corresponding angles converse. So the word converse may be a shoe, but it is also about the reverse, right? So that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So in last week's 3.2, we saw that if you have two parallel lines cut by a transversal, then the corresponding angles are congruent. Now we see if we have two congruent angles that are in corresponding positions, then the lines have to be parallel. So it's just saying the reverse of the last theorem. So knowing the angles are congruent tells us that the lines are parallel. Instead of knowing that the lines were parallel, it meant the angles were congruent. Okay, so that's what it's meaning by that converse. So again, take a second, write that down, and we see that angle 2 and angle 6 are congruent. They have one arc. They're in corresponding positions. And because those two are congruent, we can say that line J and line K are parallel. And that's what this part here is saying. Line J is parallel to line K. Okay. So this one says, using the corresponding angles converse, find the value of x that makes m parallel to n. So by the corresponding angles converse, if we have congruent angles in corresponding positions, then the lines are going to be parallel. So that means that we know corresponding positions, this angle is above its line to the right of the transversal, above its line, right of the transversal. So these two are in corresponding position. So that means that if we did 3x plus 5 equals 65, making them congruent, that's how our lines are going to be parallel. So we got to figure out what value of x lets that happen. We're going to subtract 5. We get 3x equals 60. Now we got to get x by itself. So remember, when you multiply, to get rid of multiplication, you got to divide, because when things are touching, they're being multiplied. So we're going to divide each side by 3. X equals 20. The next one is a similar idea. It says, is there enough information in the diagram to conclude that line M is parallel to line N? Well, so far, what we know is if corresponding angles are congruent. So the angle that would be corresponding to 75 would be this angle right here. Do I know anything about that angle? Is there a way for me to find out something about that angle? And yes, there is. We know something about that angle. And what we know is that 105 degrees is on the same line as that angle. Same line. Non-shared side forms a line. Means that they're linear pairs. And we know that linear pairs lie next to each other, share a side, non-adjacent sides, form a line. So that means to find this angle, we can do 180. A straight angle is 180 degrees, which is a line. Subtract the amount we know, 105. So 180 minus 105. Take a second, put it in your phone or your calculator. What do you get? Okay, so if you did that, you should see that you got 75 degrees. So now I know, I'm going to change my color pen. I have 75 degrees here. I have 75 degrees here. We know that those are in corresponding positions. They are now congruent. Therefore, we know that yes, parallel, because Shorthand for because, B/C. Because corresponding angles are congruent. Therefore, so remember the 3 dots in a triangle shape means therefore. You can't see that. I will go down a little bit further. Are congruent, and therefore M is parallel. Remember those are the 2 giant L's. It looks like L's. I call them absolute value bars. That's what it looks like to me, to N. So that says because of that, we know M is parallel to N. Okay, we have a few more theorems. Our first one up is alternate interior angle converse. Then we have alternate exterior angle converse and consecutive interior angles converse. I'm going to give you guys a minute to write those down, fill in your blanks, so then we can talk about it. Okay, so let's start talking about the first one, alternate interior angles converse. So just like the last one, it's the reverse of the alternate interior angles theorem we learned last week. So if two lines are cut by a transversal, so remember 2 lines cut by another line, so that the interior angles, interior angles are congruent, then the lines are parallel. So remember, to be alternate interior, you're inside the lines, opposite sides of our transversals. You see that's 4 and 5 in this one. And we see that they are opposite sides. We see by the 1 arc that they're congruent. And because they're congruent, the lines J and K have to be parallel. So because alternate interior angles are congruent, the lines have to be parallel. The alternate exterior angles converse says if 2 lines are cut by a transversal, so that the alternate exterior angles are congruent, then the lines are parallel. So exterior, outside of our lines, remember that, opposite sides of the transversal. So we have this one on this side. We have this one down here on this side. Opposite sides. Take away the ones in the middle so they're not super confusing. Okay, if those 2 are congruent, same measure. That's what congruent means, remember? That means that they are parallel lines. So J and K are parallel. Consecutive interior angles converse. Remember, consecutive interior angles is the one where we talk about being supplementary. What does it mean to be supplementary? Okay, hopefully you're saying out loud that supplementary means 180 degrees. So we're saying that if 2 lines are cut by a transversal, so that consecutive interior angles, so same side, inside, both on the same side of the line, consecutive interior right next to each other, are supplementary, adding up to 180, then they are parallel. So remember, this is the weird one where they have to add up to 180. Other than linear pairs, that's the only other one we know right now that does that. Okay, so we want to know, is there enough information given to conclude the following lines are parallel? So let's look at the first one. Why don't you guys take a second and then look at all 3 of these. I'm going to give you a minute and a half. Look at all 3 and tell me if there's enough information based on the things we just talked about. Okay, that was a minute and a half. So let's go through the first three. The first one, we have a 75 degrees on the inside. Do we have any other information? So we know that we could figure out this one would be 75 based on vertical angles. We know we could figure out this one based on linear pairs. 180 minus 75 equals 105. But do we have anything that relates us to this line? Is there any other angles we know there? So without them being parallel, we don't know that because this wants us to show that they're parallel, we cannot make any assumptions about that other line. So no, not enough info. Okay, next one. When you guys looked at this, what do we know about the two angles given? Is there a relationship there? What relationship is that? Well, we know that they're both on the same side of the transversal, and then they're both on the top side of their line, which means that they are in corresponding positions. So these are corresponding. So yes, corresponding. What do we have to know about corresponding angles for them to be parallel lines? Well, that they have to be congruent. So yes, corresponding angles are congruent. Therefore, M is parallel. Line M is parallel to line K. Okay, how about number C, letter C? We see we have vertical angles. We could figure out linear pairs here. 180 minus 82. It's going to give me 98. That was a close one. 98 degrees. That was a group when I was a kid. A boy band. So we see there, we have information from there. We could get vertical angles, knowing that this one would be 90 degrees. But is there anything relating us to this line over here? No, there's no other measures over there. So without any information telling us anything about that line, there's not enough info. Okay. I'm going to give you 3 more. I'll give you a minute this time. Okay, that was a minute. So when you see these little boxes, what does that tell us? Do you guys remember? So these boxes here, I'm going to highlight them. Well, that was a pretty pathetic highlight. Let me try here. Okay, I highlighted them. What do those tell us? Well, those are right angle boxes, meaning that those angles are 90 degrees. So we know this angle here is 90 degrees. You don't have to write it because we know it, but I'm writing it so you can see it. Now, is there a relationship between those two angles? So we look at their lines, and they're both to the left of their lines. What's their reference point to the transversal? They're both above the transversal. So yes, these are in corresponding positions, and they're congruent. So yes, corresponding. I feel like I'm misspelling that word, guys. I'm a terrible speller, so I'm sorry. Corresponding angles. I can't say I'm a terrible speller. I'm not the best. I wish I was better. Little tidbit about Jenkins. Angles are congruent, but being dyslexic makes it difficult sometimes. Okay, E. This one looks confusing. We know that the two inside angles are congruent. What type of angles are these? So inside their lines, interior, same side of the transversal, tells us these would be consecutive interior angles. Well, consecutive interior angles, for them to be congruent, we have to add up to 180. Well, right now we just know that we have two angles of the same measure. Do they necessarily add up to 180? No, there's not enough info. There's only one case where that's true. If they were both right angles, they'd both add up to 180. And that's the only time that they'd be congruent and make it where they'd add up to 180. Okay, the last one, what's the relationship between this angle here and this angle here? They're on the outside of their parallel lines, opposite sides of the transversal. So this means that they're alternate exterior angles. And we know if alternate exterior angles are congruent, then our lines have to be parallel. So yes, alt exterior angles congruent. That's a terrible congruent sign. Congruent. Therefore, A is parallel to B. I didn't say it on D. Let's go back. So those angles are congruent. So what is parallel? R is parallel to S. I'm going to erase that little mark I had there before I did it. Okay, excellent job, guys. Example 3. So example 3 says, find the value of the variable that makes the lines parallel. So we have to talk about the relationship of the two angles. So both angles are on the inside of their lines, to the same side of the transversal. So they'd have to be consecutive interior angles. What do we know about consecutive interior angles for them to be parallel? You need a second, go back, flip to that first page. Consecutive interior angles to be parallel have to add up, because they're supplementary, to 180. So we're going to add those two. 2x plus 4x is 6x equals 180. To get that x by itself, we're going to divide by 6. X equals 30. Okay. Over here, what's the relationship between these two angles? They're both outside of their lines. So outside the parallel or outside the lines. We don't know that they're parallel yet, but we want them to be parallel. On opposite sides of the transversal. So these are going to be alternate exterior. Outside the lines, opposite sides of the transversal, alternate exterior. And alternate exterior angles, for them to be parallel, have to be congruent, which means they have to be equal. 3x equals 105. We got to get x by itself. We're going to divide by 3. Okay, x equals, take a second, put it in your calculator. You should have arrived at x equals 35 degrees. Okay, guys, we're almost there. We're going to skip these two. Okay, transdib property of parallel lines. I'm going to give you a second to fill in your blanks. Okay, so the transdib property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So if we see here, let's do green. If P is congruent to Q, or is parallel to Q, P is parallel to Q. Remember, we show parallel by arrows, and we know that R is parallel to Q. I did them in different colors. Traditionally, we would use more than one arrow. So you'd have two sets of arrows close together. So we have P is parallel to Q and Q is parallel to R. Well, since they're both parallel to Q, we know that P has to be parallel to R by the transitive property now applied to parallel lines. So using the transitive property of parallel lines, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Okay, so if it's parallel to the one directly below it, we know that S1 is parallel to S2. And we know that S2 is parallel to S3. And we know that S3 is parallel to S4. We know that S4 is parallel to S5. Okay, I'm going to use ... because we see that this trend is continuing, right? We know that S8 is parallel to S9. And we know that S9 is parallel to S10. I don't know why I didn't go further. S10 is parallel to S11. Okay, S12 is parallel to S13. So every time I did the ... that's just telling you that we had some more of these going on. At line S, or S5 is congruent to S6, S6 is congruent to S7, S7 is congruent to S8, and it picks up S9, 8 is congruent to S9, and then again S11 is congruent to S12, that's the only one that's missing there. So now we see that we have this whole thing where one's parallel to the next one, which is parallel to the next one, which is parallel to the next one. So we see that, I wanted to figure out a spot I can write that won't be because of the transitive property, the one we just learned, of parallel lines. We know that S1 is parallel to S13 because if it's parallel to the same thing, they have to be parallel to each other. Okay, that's it for today, guys. Remember to ask questions when you have them. Reach out, send me emails. I have office hours that you can sign up for on Google Classroom. Talk to you soon. Bye.